Hi everyone. Good evening, guys. So this is visible, everyone. Audio both are clear, all of you. Everyone, audio both are clear. Right now it has got late actually, so same problem as that of yesterday. Right now it's clear, all of you. Everyone, it's clear or not? Somebody just confirm. Only Ritesh. Right. Good evening. Right. Directly you said B. What is it B? Right. How are you? How are you guys? Everyone? Right. So now we'll be continuing our discussion on this centroids and moment of inertia, GATE PYQs. You can say, right, GATE PYQs of this engineering mechanics. Which one? This is centroids and this moment of inertia, if you just observe, right? And all of you, welcome to Unacademy. Let's crack it, right? Clear now, Akhil? Good evening. Okay, very good. Now, this is my profile. You can follow me at which, and what is the referral code you have to use always, everyone? RP Civil Live is a referral code you have to use now. Yes, RP Civil Live is a referral code you have to use always whenever you are subscribing to the Plus and Iconic courses, right? Inform your friends also to use the same, right? And now coming to this is a plus course going on, full length course on this surveying every day 8:15 to 10:15 p.m. it is going on except Sunday. So now GATE PYQ series on this transportation engineering is going on. So the 9:32 which one? This is 9:32 which one? This is 10:15 and 9:32 this 10:15 a.m. every day it is going on. And GATE PYQ series of this engineering mechanics we are discussing in this YouTube, right? So 4:30 p.m. to 5 p.m. Monday to Thursday it will be going on, right? But only this week we'll be having up to Saturday, but next week onwards it will be from Monday to Thursday only, right? Other days it will not be there. So now, so this is you know about me, and this is our Telegram channel. You can join, and this is a special combo offer you are having, right? Those who are willing to prepare for which one? Those who are willing to prepare for this GATE as well as this SSC and state AE examinations. This is a here is the opportunity, right? 6 months GATE subscription if you are taking, 1 month extra. So 24 months GATE and ESC subscription if you are taking, 12 months that SSCG and state AE you are getting, right? So don't miss this opportunity, all of you. RP Civil Live is the code you have to use always. Yes, na? Right. So price hike is going to happen again. So to avoid this price hike, all of you use the referral code RP Civil Live and subscribe now itself, right? Before the price gets increased. So now on 17th June at 12 p.m. this is a test you are having, right? Guaranteed scholarship test, that is the ultra combat test is happening. So don't miss this, everyone. RP Civil Live is the enrollment code for this you have to use, right? So Pado Kilo Cracker series is also going on, you know already. So this you can get the GATE printed notes, right? Already existing plus and iconic subscribers also you can get this. Here is the opportunity, only limited time opportunity. You can subscribe to them and use the referral code RPC will have, right? So this is the difference between this plus and iconic fee, and this is every month when you are taking this iconic subscription, every month you will be having the 2 interaction sessions, right? This is the difference between the criteria, right? So what are the things you will be getting in place, what are the things you will be getting in iconic, right? You will be getting here, right? Depending upon this you just choose which one is required for you, right? So those who are unable to pay the fee at a time, Unacademy has introduced this no cost EMI option, everyone, right? So these are the new batches started on which one? This is July 7th, everyone. So don't miss these batches. Use the referral code RP Civil Live, right? What is the referral code you have to use always? RP Civil Live is the referral code you have to use, okay? For any batch you are subscribing to, right? So here also this is a fee structure, you can say. RP Civil Live is the referral code you will be using, right? So this GATE PYQ is yesterday we have done, so on which date it is done? On this 13/7 that 22 it is done. So now lecture 2 we will be entering into, right? Up to which one we have done? Up to this 3 questions we have done in yesterday's class now. So now, so this is lecture 2 GATE PYQs of engineering mechanics, right? On which one today's class is what? 14 and 14/07, which one? This is 2022, okay? Right. So question number 3 and this is your question number 4, right? So select the answer, everyone, all of you. Yeah, Sharath, good evening. Select the answer for this question, everyone. Select the answer for this question, everyone. Everyone write this question. Write the answer for this question, all of you. Somebody select the answer, all of you. So in civil engineering, very simple questions only given engineering mechanics, but mechanical engineering, very tough questions are given if you just have, right? So after this, we'll try to move into some mechanical questions also, all of you, right? So don't worry. We'll be moving into which one? This is some mechanical questions also, right? Some mechanical engineering questions also we'll see. Anyone? Nobody is selecting the answer? B. Lina said B. Any other answer by others, all of you? Any other answers by others? Akhil said A and Sharath said B. Lina said B. Okay. So shall I start solving? Shall I start solving, all of you? Okay. A disc of this radius, right? A disc of radius R has a hole of radius R by 2 cut as shown, right? How it is cutting, if you just observe, it is cut in this format, right? Where it is started? It is started here and it is ending there, na? So now you have to be careful, right? So that a shaded portion means the remaining portion, na? So the centroid of this remaining disc, right? Remaining disc means this is a shaded portion, na? That remaining shaded portion. After this hole is removed, we have to calculate it at the radial distance from the center O is, right? With respect to which one we have to calculate? From this O only we have to calculate, na? Everyone, from this O only we have to calculate, na? From this O only you have to calculate, if you just observe, right? When you are calculating it from O only, right? Let us say this is your page number 1. You can say, how can you calculate it? If you just observe, you can say that distance of this is centroid, right? For which one? Distance of which one? This is centroid of what? Distance of this is centroid of this disc without hole, right? It is which one? This is without hole from O, right? What is it from O? You can say that is nothing but your x1, right? How can you get this? Is it not this 0, everyone? Is it not this 0, all of you? Is it not that 0? It's not, because that itself will be, right? How can you convert this, right? You can convert that into which one? This bigger circle minus which one? This is smaller circle, you can say, right? Bigger circle minus this is smaller circle, right? Whenever you are considering this original disc, right, what is that you are having? So this is O point, right? Centroid of this entire circle disc will be there at this O point only now. So therefore, what is the distance? X1 is 0, right? And what is that? A1, you can say area of this one, if you just observe, area of this, right? Area of what? Disc. Area of this disc without hole A1, if you just observe, right? How much it will be? That pi by 4 into that R square, na? Pi by 4 into that R square, if you just observe, right? Now if you just observe, what is the distance of this centroid? Distance of this hole. Distance of this whole centroid from where? From O. How much it will be? Let us say it is given with the symbol x2, right? Where it is present, if you just observe, you can say where it is present, if you just observe, everyone. Where it is present, if you just observe. So this is your R by 2, na? So here also it is R by 2 only or not? Yes or no? So that total diameter is radius is R by 2, diameter is R. So what is that? You can say from here to here also it will be R by 2 only or not? Yes, that is your R by 2 only, right? What is that? You can say that x2 will be equal to that R by 2, if you just observe, right? And what is that area, if you just observe? Area of a hole. What is that area of this hole? If you just observe, area of this hole A2 will be equal to that pi by 4 into which one? This R by 2 is the radius, na? Pi by 4 into that R by 2 square, right? So now if you just observe, what is that final centroid? Centroid of which section, you can say? That is centroid of which one? This final section, right? How can you get centroid of this final section? From where? from O na, from this O point you can say it, because x1 x2 both are taken with respect to O only, so we'll be getting it O only, no, net value. What is that? You can say that x bar is equal to that a1 x1 minus which one? This is a2 x2, right? a1 x1 minus this a2 x2 divided by which one? This is a1 minus this a2, right? Mod value we have to get it, right? Plus or minus whatever it is, right? So if you are getting it as plus means right side, if you are getting it as negative means left side, right? What is that? a1 x1, so this x1 comes to be 0 na, that x1 is 0. What is that? You can say minus a2 will be how much, everyone? That is your pi by 4 into, right, r square divided by this 4 na. So pi by 4 into r square divided by this 4 you can say, right? Divided by what is that? a1 minus a2, a1 pi by 4 if you take a common, what is that? R square, first one is your r square minus this, second one is your r square by this 4 na, right? So now what is that value of this x bar you will be getting finally? Therefore that x bar you calculate it to be r by 6. Is that clear, everyone? Everybody is getting that same r by 6 only. So option C will be the correct answer, you can say. Is that clear, all of you? How to get this, everyone? So this is your GATE Civil Engineering 2010 question. Clear, all of you, everyone? Everyone, it is clear or not? Somebody? Clear? Someone confirm? All of you, it is clear or not? If it is clear, I'll just try to move on to which one? This is the next question, right? That is your fifth question, right? If it is not clear, I'll explain it again. Yes, no? Right. So just skip this, right? What is that? You can say fourth question is over now, and this is your fifth question, right? This is your fifth question, you can say. Write your answer, all of you, for this fifth question, everyone. Write your answer for this fifth question, everyone. Write your answer, everyone. Anyone? C, right? Lena said C, and Sharath said C, and Akhil said C. Everybody said C only, right? We'll check it now. For the section shown below, right? For the section shown below, the second moment of area, right? What is the meaning of this second moment of area? Second moment of area is nothing but your section modulus, sir. It is a moment of inertia only. Yeah, Shekhar also said C. It is moment of inertia. Aina. About an axis, right? About an axis where it is d by 4 distance above the bottom of this area, right? You have to consider this is section, right? Array. One sec, one sec actually. So before we enter into that, we'll just add one extra slides here. One sec, all of you. Right. So here, so what is that you are having? If you just observe it, that section will be taken at which distance? At a distance equal to how much? D by 4 from the bottom, na? So no, that section is D by 4 from the bottom, right? So this is your which one? This XX section about which you are supposed to calculate this moment of inertia, right? So this is at a distance of this D by 4 from the bottom, right? So now if you just observe the centroidal axis, right? What is that centroidal axis? This is your GG centroidal axis, right? From, so where is that centroidal axis? If you just observe from the top, it is at a D by 2 distance from the top, and it is at same D by 2 distance from the bottom only, na? Yes or no? And now tell me, what is this one? You can see if you just observe, right? This is at which distance? If you just observe, this is at which distance, everyone? So this is at a D by 4 distance you are having, na? This is at a D by 4 distance you are having, right? Now if you just consider moment of inertia about what is that moment of inertia about this x axis, if you wanted to get it, moment of inertia about its centroidal GG plus area of this entire one into that h square, right? What is that h? You can say from the centroid to this axis, right? How much distance, right? What is that you are having? Moment of inertia, right? What is that moment of inertia? How much, everyone, all of you? How much it comes to be, everyone? That is your BDQ by 12, na? Yes or no? That is your B into that DQ by this 12 plus what is that area of this rectangle? B into D into what is the distance h, you can say. So moment of inertia about the centroid is known, and at which distance we want the moment of inertia, right? On which section we want the moment of inertia. So centroid to this section where you require moment of inertia is h, right? What is the h, you can say? Can we say this h is equal to d by 4? Yes, d by 4 square, right? So that d by 4 square, if you just observe, right? What is that Ixx comes to be then? What is that Ixx comes to be then, all of you? What is that Ixx comes to be, all of you? Everyone. What is that Ixx, all of you? Somebody check it. Total value, how much it comes to be? Video struck. Now it is okay? Now it's okay or not? That is 7 BD cube by 48, if you just observe, right? 7 BD cube by this 48, right? Is it struck for everyone? One sec, let me check it. What's happened? One second, all of you. Or not? One sec. Audio you are getting? Only video problem? One second. It's not working. It is okay, everyone, now? I think now it will be okay. It must be okay, everyone, for everyone. So what is that you are getting if you just said BD cube by 12 plus this BD area into what is it, h distance, you can say, from the centroid to this x axis, that d by 4, na? So 7 by 48 BD cube will be getting, right? 7 by 48 BD cube, right? Which option it will be? Option C will be the correct answer, na? Option C will be the correct answer, right? Now this is, so with this civil engineering mechanics questions got over, right? Now tell me, is there any difficulty in this civil engineering mechanics questions? Civil engineering mechanic questions are very easy, you can say, right? Now coming to this is your mechanical engineering, right? So this is your question number 6, mechanical engineering question, right? This is your mechanical engineering. When it is given, 2003 it was given, right? Now select the answer for this question number 6. Write the question number and answer, all of you. Everyone, write the question number and answer. Shekhar said D, Sharath said D. Everybody? Right. So what is that? The second moment of area. Second moment of area of a circular area. Sorry, it is already given. A second moment of a circular area about the diameter is given by, right? What is the second moment of area? It is nothing but your moment of inertia only now. So what is that moment of inertia for a circular with diameter capital D? If you just observe, with the diameter capital D, right? What is that moment of inertia? I, if you just observe, that moment of inertia about this x axis or IgG, right? Moment of inertia about its centroidal axis is what? That pi d power 4 by this is 64. Yes, now that pi d power 4 by this 64, and option D will be the correct answer, right? Now select this question number 7. This is also mechanical engineering question only, all of you. This is also which question? Mechanical engineering question only. So this is already right. Now calculate the answer. Sorry, in remaining disk, it is already done now. Yes or no? It is already done. Okay, no need to do it again. So it is already done now. This is R, not pi by 6. It is R now. This is R, right? Not pi. It is already done. In civil engineering it is given, and in mechanical engineering also it is given, right? So you don't take this. It is not required. Question number 7 we'll take it now. So this one you take it as question number 7, right? So mechanical engineering 2015 set 3 question, right? Like that. Select the answer for this. This is done. This question I am asking, right? This question it is not done now. You just do it, everyone. This question number 7 done? No, no. It is done or it is not done? This one, question number 7, you select answer, all of you. You just call me Sharath, I'll tell you. Call me. Yeah, this you do it, all of you. Okay, after this question we'll close it, right? So mechanical engineering questions are little bit higher level compared to civil engineering questions, all of you. Okay. Do it and tell me the answer, all of you. B is the answer. Okay, Sharath, you can call me after the class, no problem. This is mechanical engineering 2015 set 3 question. In civil engineering we are having set 1 and set 2 only, but mechanical set 3 also will be there. Done, everyone? Do it. Only Shekhar said it B. What about others? What is the answer, others, all of you? The value of this moment of inertia of this section shown in the figure below, about which axis you can say, about this x axis you are asked to identify, right? About this x axis you have to calculate. Yeah, Shaker said yeah. From B you have shifted to A. Why like that? Okay, we'll just do it. Okay, I'll do it, right? It will take more time for you. I'll do it then. This is your second page. This is your third one, fourth one, fifth one, sixth one, and seventh one, right? So what is that you can say that a moment of inertia, right? Akhil said, see that moment of inertia about this xx will be equal to, what is that you can say that a moment of inertia about this xx for which one? This is a rectangle minus 2 times which one? This moment of inertia about this xx for which one? This hole, na? Isn't it? Because two holes are there, na? Yes or not? Two holes are there or not? Hole, right? Which hole? If you just observe, that is a square hole. If you just observe, right? What is the moment of inertia about this xx for this rectangular one? If you just observe, this is your 60, this is your 120, na? So what is that you can say that is your 60 into, right? 60 into that 120 cube, right? BD cube by this 12, 60 into this 120 cube by 12, right? Minus 2 into, what is the moment of inertia of this hole about this xx? Now tell me, moment of inertia of this whole about its centroidal axis is what? 30 into that 45 cube by 12, na? So that is your 30 into that 45 cube, right? Divided by this 12 plus what is that area of this whole 30 into 45, na? So that is your 30 into that 45 if you just observe, right? Into what is that you can say h square, na? H is nothing but centroid of this one to this x axis, right? What is this distance? This is your h you are having, right? How can you get this h, everyone? So this total is 45, right? This is your 15, right? 15 plus 45 by 2, na? H is equal to 15 plus which one? So this is your 15 plus half of this 45. 15 plus this 45 by 2. So what is it you can say that 15 plus this 45 by 2 whole square. Now tell me the value Ixx, how much you are getting, all of you? What is the Ixx you are getting, everyone? How much is that Ixx all of you are getting? Option B is matching, right? What is that option B? 6.8850 into 10 power 6, right? 6.8850 into 10 power 6 millimeter per 4, right? All of you are getting the same value or different value? All of you are getting the same value or anyone is getting different value? Everyone is getting the same value or different value, all of you? Everyone is getting the same value or different value? Same value only you are getting? Clear, everyone? Somebody, any other answer by others? All of you? If any other answer by others, just tell me. So because that I for this whole, right? What is that I for this whole about this xx you can say? That is nothing but your moment of inertia for the whole about its centroidal axis plus area of this whole, say area of this whole into that h square, right? Others I am asking Sharath. Okay, any others also getting the same value or different value? Others also must be getting the same value, na? Yes or no? Right. So there is one more question in GATE 2016 given, right? But we'll solve that. Okay, all of you. So this is your question number 7, right? I did not bring it. Question number that is your question number 7 got over, na? And this is your question number 8 I will be making. So what is it you can say? Calculate moment of inertia about base for the following. In which one? In a millimeter per 4, right? In millimeter per 4 if you just observe, right? So what is the, you can see it is actually given as which one? This is a GATE mechanical engineering, right? Not civil engineering, right? GATE ME, which one? This is a 2016 set 1. 2016 set 1, right? This question is given, right? Civil questions are very simple only, but mechanical questions only little difficult enough. Yes or no? If you just observe, right? What is that you are having? You can say. This is your mechanical engineering question we are having, right? So you try to solve this question, everyone. So the total is which one, right? This is your centroidal axis, you can say, exactly. So what is that? This total distance is your 10 millimeter. All dimensions are in millimeter, right? So this is your 10 millimeter, and what is this one also, right? This is also your 10 millimeter na. And what is it, you can say, if we just observe, right? This dimension is given as which one? This 8. Okay, this dimension is given as your 8 millimeter. And what is it, you can see, if we just observe, right? This distance, what is the distance, everyone? This distance comes to be r by 4, right? This is radius will be which one? This r. Okay, what is that r? You can say that radius r is equal to 4 millimeter na. That radius r is equal to 4 millimeter, or you can also represent it as which one? This r4, right? What is the meaning of this r4? R4 is nothing but your radius 4, right? So tell me the answer, everyone. So try to solve this, all of you. This is GATE mechanical engineering question, right? So 187.75.66 millimeter per 4. Second one is what? 1675.6 millimeter per 4. And what is the C? You can say 1975.6 millimeter per 4. Option D, none. Solve this, everyone, all of you. So after this class I will be sharing this centroids PDF, okay? Because one topic gets over na, engineering mechanics GATE PYQs of centroids I will be sharing in the groups, okay? I will be sharing in my community also. Width 10, sorry, yeah, width is also 10. Okay, is that clear, Sharath, now? Right, any data, any other data is missing? I think no. Just check it. Do it and check it, everyone. I don't know what is that answer, whether it is B or C or D. You solve it and let me know the answer. Solve this, everyone. So I'll give one hint, right? You can convert that into which one? If you just observe, you can just convert that as which one? This is a rectangle, right? You will be getting the moment of inertia for this also same na. This is your rectangular, right? What you are doing, you just consider these two semicircles in this manner as a circle, okay? So like this you can do it, right? So this is how you can convert it, right? This hint I can give. So when you are converting that into this manner also, you'll be getting the same answer, right? Because the left side is semicircle, right side semicircle hole, so you can make it, right? Yeah, Sharath 1875.6, right? Any other answer by others, all of you? This is your which one? This is GG, right? Centroid na. And what is the axis about which we have to calculate, right? About this base xx we have to calculate na. About this base xx we have to calculate, right? So now how can you get this moment of inertia? That is 7th slide, 8th slide. This is your 9th slide, right? How can you get this moment of inertia? If you just observe that a moment of inertia about this xx will be equal to, what is that you can say? That a moment of inertia about this xx for this rectangle, okay? Minus which one? This moment of inertia about this xx for this which one? This is circle, isn't it? Yeah, single circle you consider, right? Moment of inertia of this rectangular section about xx minus moment of inertia of the circular section about xx, right? So what is the moment of inertia of this rectangular section? If you just observe, that is your IgG plus which one? IgG plus this AH square na, minus what is that you can say? Minus this is for the rectangular section, you can say. and what is that you can say, that is also that IGG plus this AH square na. So that is for which section? If you just observe, this is circular section, and what is that IGG for this rectangular section? Moment of inertia of this rectangular section about its about its centroidal axis is what? This is 10, this is 10 plus 10 20 na. So 10 into BD cube by 12 na, 10 into that 20 cube by this 12 plus what is that area? 10 into 20 is that area into what is that you can say? H. What is that H you can say? If you just observe, H is nothing but your 10 na. So no, H is nothing but your 10 you can say, right? So for this H, what is that you can say? That is your H1, right? H for this rectangular section, right? 10 na. So that is your 10, right? Into 10 square minus what is that you can say? Moment of inertia for this circular section about its central axis, pi d power 4 by 64 na. That pi by 64 into what is the diameter you can say? That a diameter is your 8 na. Pi by 64 into that 8 power 4, right? Minus what is that area? Pi by 4 into that d square na. Pi by 4 into that 8 square is that area into what is that H2 you can say? If you just observe, what is that H2 you can say? If you just observe, same H only now. So for this H for the circle is also same na. H for this circular section also same na. So no, centroid of this circle to the base same na everyone. So what is that you can say? That is your 10, right? 10 is square, right? Now simplify this. What is that IXX you are getting everyone? How many millimeter per 4 you are getting? Just to check it everyone. How much you are getting everyone? All of you? Same you are getting 187. This is 8. Is it 8? H will be? Yeah, okay. So pi by 64, 8 power 4 minus pi by 4 into that d square. That is diameter, right? Because the diameter is given as 8 millimeter. Na? This is your diameter. And but what is that H you can say? About this base, right? Base is XX na. For this rectangular section and for this circular section, right? H for this rectangle and H for this circle both will be same na. 1875.6, right? 1875.6, right? Now civil engineering mechanics questions are easy, but mechanical engineering mechanics questions are little tough you can say, okay? Right, which one is the correct answer now? Option A will be the correct answer now. Option A will be the correct answer, right? Like that. So this completes which one? This GATE ESE, GATE engineering mechanics questions from this centroids and moment of inertia, right? All of you subscribe to this channel, and you will be getting the PDF. Don't worry, you like this video and share it with your friends, right? So you will get the PDF in the community, right? Where you will be getting the PDF in community. PDF in community you will be getting, all of you, right? PDF in community you will be getting, so don't miss this, right? I'll be sharing in my community, right? Start following that. So for this chapter I'll be sharing it, right? Shall I close the session everyone? Shall I close the session all of you? Yes, I'll be closing the session. Thank you all of you. Anyone having any doubts? Anyone having any doubts, all of you? If no doubts, I'll close the session, right? Thank you.